Welcome to my tutorial on the BV512 vocoder in Reason 4. I'm going to start first by creating the actual mixer we'll need and the vocoder itself. Now I've actually done this on purpose. Sometimes when you add the vocoder it'll rewire some of its neighboring units. It'll seem to think that you want to use them as carrier and modulator signals. So if we just take a look at the back first of all, you can see the vocoder is actually taking the master output of the mixer as its carrier input. So we'll disconnect that, we don't want that. If you also have a look here, you'll see that the output of the vocoder is going to Reason's main output, channel 1 and 2. So again, obviously we don't want that, so we'll disconnect that. And we reconnect everything correctly, the master out of the mixer, back to channel 1 and 2 out. And we take the output of the vocoder to the next channel on the mixer, which here is obviously just 1. So how the vocoder actually works, it requires two signals to work, a carrier and modulator signal. Modulator is analysed through a series of bandpass filters, and the vocoder is then able to determine the amplitude envelope of specific frequency bands. Carrier signal is then analysed by the same number of bandpass filters, and the coincident amplitude envelope of the modulator being applied to the carrier signal. A good modulator signal is any signal which is rich in spectral variance, and the most obvious being the human voice, and the easiest way to get the voice into Reason is through Rex files. So I've loaded up a Dr. Rex loop player, and I'll just quickly find my vocals, which is here in my loco. The time is right. Now if I press play on this, have the signal play, you'll see straight away that it's being picked up as a carrier signal in the vocoder. So this isn't actually what we want. We want this as the modulator, so we just disconnect it here from the carrier input. We take the output of the Dr. Rex, send it to the modulator there, and you'll see now that it's being picked up as the modulator signal. Here you'll see each individual bandpass filter and what it's doing. Just below, you're able to control each individual filter, turn it up and turn it down as you please. And you can select anywhere between 4 and 32 bandpass filters. Obviously 4 is not going to provide that much of an envelope, and 32 is going to give you as much definition as possible. So if we have a look at the back again, we'll see that we need a carrier input next. So a good carrier signal is any signal which has a constant dynamic and is rich in texture. So a good example would be strings. I have an NXT loaded up here, which is routed correctly the output 1 and 2 into the carrier input. So now we just need to load up the appropriate patch. So we open this, click on strings, and anything here will do. Yeah, redemption is fine. So if I play some notes here on my MIDI keyboard, straight away you'll see under the carrier input meter that the vocoder is reading the strings as a carrier signal. And you can clearly hear that the vocoder is working. So that's the sound of the vocoder using the bandpass filters. There's also an FFT function here, which stands for Fast Fourier Transform. Now this process actually changes a signal from the time domain to the frequency domain. It takes a signal and breaks it down into a sum of all the sine waves involved in that sound. So the envelope of each frequency is then analysed and applied to the carrier signal through a process called IFFT, which is simply inverse FFT. 512, you'll see here 512 bins, simply means 512 bandpass filters. So if I play this again now on FFT, straight away you'll hear the definition is clearer. And that completes my Reason tutorial on the vocoder.